isn't it? So what is delta? The difference between these, isn't it? So what is the difference between 2 and 5? 5 second minus first, isn't it? Final minus initial. 2 minus 5 minus 2, you get that difference to be 3, isn't it? Then the next difference, the next two values, this is 10. Is 10 minus 5. Are we together? This is the second minus first, okay? 10 minus 5? 5. Then the next difference is here, 17 minus 10, you get? Then the next difference is here, 26 minus 17? 9. Good. Then after getting the first finite difference, we go to the second finite differences. That is now delta squared, isn't it? So delta squared we have is here. The difference is here. 5 minus 3. Then the next difference is here. 7 minus 5. 2. The next difference is here. 9 minus 7. 2. Are we together? Ladies and gentlemen, the next one is delta cube. So move, the difference here is 2 minus 2. The difference here 2 minus 2. So are you seeing? Meaning delta cube is making it a cubic polynomial, isn't it? So it means this thing is not a cubic polynomial because 0 times anything there is going to be 0, isn't it? So it means it is a quadratic polynomial. It is going to reach here. Are you seeing? Are we together? Good. Now, let us start. Which is the first value you've been told to evaluate? You've been told to evaluate f of 1 point, f of 1.5. So when x is 1.5, where is x? 1.5. 1.5 is between 1 and 2, isn't it? So it means we are going to have our values here. X naught there, and that is x1. So our x, 1.5 is in the middle there. Are you seeing what is happening? Meaning, the value we are looking for is here. So we don't need that interpolation polynomial. We just get it direct. Are you getting it? Are we together? So you come and you draw a line where you have your 1.5. You say your 1.5 is in between here. There. So the f and x value. So you see, am I going to move backward or forward? You see, when you move backward, there will be no value, isn't it? But when you move forward, there will be values, isn't it? Are you seeing our line where for 1.5 is here? So it means when we move backward, it's like that. We are going back to where we started, isn't it? See, there are no values there. But now, when it is here, when we move forward like that, are you seeing there are values? So it means for you to evaluate that, you're using the forward difference formula, isn't it? So when we move forward, you see the first values to get are those. So you cross those, you let your line pass where you want to evaluate there. Are you seeing we found where we are going to evaluate the function when x is 1.5? Are we together? Good. So after getting that, we need to get what? P, senior. What was P? We have the whole interval here, x0 and x1. The whole of this length was h, isn't it? And where we are evaluating the value is here at x. So it is this smaller length, meaning P is going to be this interval minus the whole of this interval, isn't it? Are we together? And this interval is x minus x0. Over the whole of this interval is x1 minus x0, which is h, isn't it? Are we together? Yes. So if you look at this table, you can see your x0 is 1. So where there is x0, this is 1. Your x1 is 2. And your x, you've been told, is 1.5. Are you seeing that? Tuko pamoja? See, your x here, you've been told, is 1.5. Yes. So if you substitute these values, what do you get to be? With x minus x0, 1.5 minus 1, you get 0.5 over h. H is the whole of this interval, x1 minus x0, isn't it? That is 2 minus 1. You get it is? Are we together? So what is b? 0.5. So we found b to be 0.5. So you just come here and you say, when we are evaluating this 1.5, our p we will take to be 0.5. Are we together? We are still looking for p. Is when we go and we see. So after getting that p, we now start. Go to the binomial problem. So binomial, if you have 1 plus x raised to power n, what do you get? The first two terms is 1 plus nx, isn't it? Are we together? Yes. Then the next term, remember when it is 1, it means when we have n factorial, it is n into n minus 1 into n minus 2 into n minus 3 factorial in that order, isn't it? So you start, when you are expanding 1 plus x raised to power n, you start from 0 factorial, means there is no term in the numerator, then your x is raised to power that 0. Then the next, when you have 1 factorial, it means there is 1 term in the numerator, and that 1 term is that, n. Then your x is raised to power that 1. Then plus, when you have 2 factorial, it means there are 2 terms in the numerator, and 2 terms is here, this and this. That is n and n minus 1. Then your x is raised to power that 2. Then when you have 3 factorial, it means there are 3 terms in the numerator, 1, 2, 3. So you see, we don't need to go 3 factorial, means x will be cubed. And you see, when we have delta cube are 0, so it means those whole terms are going to zeros, isn't it? Meaning we don't need them. Are you seeing that? From this problem, delta cube is 0, 0. Meaning when we will be multiplying anything with 0, the whole of it will go to 0. Meaning this term where we are going to have 3 terms in the numerator, n into n minus 1 into n minus 2, x cube. This x cube, the term where we have the cube, will go to zeros onwards, isn't it? So it means we don't need those other terms. We will reach here according to this table, according to the finite difference table, isn't it? Are we together? According to the finite difference table, it is telling us that anything past delta squared will be zeros, meaning they will not be working. They will go to zeros, all of them. Okay? Are we together? Yes. Good. So after this, you now simplify this. You have 1 plus x raised to power n. 0 factorial is 1, x raised to power 0 is 1. 1 times 1, you get 1 plus 1 factorial is 1, x raised to power 1 is x. N times x is nx. That's why we have 1 plus nx, isn't it? Then the next term here is now where we have plus our 2 factorial there. Then you made the 2 terms, n into n minus 1, then our x squared. So we have found the binomial expansion. We found the binomial expansion, meaning we don't reach x cube. When we reach cube, it will be zeros. We don't need those zeros, okay? Are we together? So from here, you now start. Where there is x, we are going to have 1 plus delta raised to power p. Meaning where there is x, you put delta. Where there is n, you put p. Are we together? Where there is x, you put delta. Where there is n, you put p. So start. This is 1 plus n is p, x is delta. See, that is p delta. Are we together? Then you move, n is p. That is p into p minus over 2 factorial. And your x is what? Delta. So, and it is delta squared. So you substituted x with the delta and you substituted n with the p. Are we together? So when we are now going to get the forward, we want to deal with the forward difference formula, meaning we multiply by f naught, isn't it? Are we together? So it means we multiply all through by f naught. So 1 times f naught will be f naught, f naught, f naught. So that is for the forward. Are we together? When it is for backward, it will be just f naught, then f negative 1, f negative 2, meaning negative 2 to correspond with the power 2. Are you using that? For the backward. Are you using for the backward, you get it from the forward. Are we together? So for the forward finite difference formula, you just multiply all through with the f naught. So we have delta f naught, meaning this is delta f naught. So we just put f, meaning when it is forward, we'll add the 0 for the delta. That's why I was leaving that f outside. In that, when it will be backward, you will make them those negative 1, negative 2. But when it will be forward, it will just be f naught, isn't it? Are we together? So that is why I did not put it there, because you don't know whether you are going to deal with the forward or backward. Okay? So this is now for general. Is that okay? Is that okay? Good. Now once we have the formula, we now go to the first function we were evaluating. So this function we've expanded is the what? Is the f of x. So this expansion is the f of x, which is equals to what? It is the f of x, which is equals to the whole of this. So this f of x is what? What is f naught? Okay, before we substitute, let me just say f of x is f naught plus p delta f naught plus p into p minus 1 over 2 factorial delta squared f naught. So that guy starts substituting. That is f of x, but now I'm now looking for f of what? Because f of 1.5, p is what? 0.5. Are we together? So what is now f of 1.5? This is f of x, but now what is f of 1.5? F of 1.5, it means our p is going to be 0.5. And our deltas, we already crossed the line there, isn't it? So start. What is f naught from your line? You go to your line, it is what? It is 2. Then plus, what is your p? You found it is 0 point. Then times delta f naught, the first delta. What is on top there? Are you seeing? Yes, remember we were evaluating 0.5 here, so when we move forward, the first value we reach is 3, then the next one is 2, then the next one is, are you seeing how that ruler is moving? Are we together?
Yes.
Good. So our delta f naught is 3, then plus our p is 0.5 into 0.5 minus 1, isn't it? Are we together? Write for me that in simple terms. P is 0.5. Then 0.5 minus 1 is negative 0.5 over 2. Then what is delta squared f naught? Go to the column of delta squared until you reach there. Delta squared f naught is 2. Meaning this one is times. We reach there because when we go to the next step, it will be 0. 0 will take everything to 0. That's why we left that, isn't it? Are we together? Yes. So start. Use a calculator to give me the value. Yes. Some?
Yeah.
Here.
Yeah.
Here.
No.
Here.
In our second.
This one.
Upward.
Here.
P.
Yes.
F naught. If we substitute P 0.5.
Yes.
Our delta is 3 times
Yes.
F naught.
It is delta f naught. Look here. This is the change. When you're looking for the gradient of a line, for instance, it is the change in y over change in x. Which change are we looking? See, we are looking for the change in f. Change in f is second minus first. So it means this delta is delta f. So I'm not putting those f because they are the change in f. 5 minus 2. That is change in f. So I'm not putting f because there's a time when we use f naught for forward. And there's a time when we use the negative 1, negative 2 for the backward. Are you getting the concept? Meaning these are change in f's. Unaelewa sasa? So when it is backward, it means if this one is delta squared, I will put here negative 2 to represent the backward. If it is forward, it will just remain f naught. That's why I was leaving the f's outside, so that both backward and forward is treated. Or you can just put the f's, but you don't put your zeros or negative 1, negative 2s, because you don't know whether you are going to make it forward or whether you are going to make it backward, isn't it? Is that understood? Yes. Very good. So it means we just leave them as f. We put the f's there to avoid that confusion, okay? Very good. So the f's are now there. You can now see what is happening, okay? Very good. So start. Use a calculator to get the whole of this value at once. Here I have to use a calculator to press, because the calculator can press the whole of that thing. What do we have here? 2. 0.5 times 3. 2 divided by 2 factorial. 1.5. Good. 1.5. Then you move again. 2 divided by 2 factorial. 1. 5 times negative 0.5. No, 0.5 times negative 0.5. And I don't expect you to be doing this. I expect you to get the whole of this value once, isn't it? And what have you found? 3.25. And you are done. You have evaluated f of 1.5. Are we together? Because we already have the formula, if it is backward, this naught is what we are going to change. Then, if it is backward, the f naught, when the power of delta is 1, we put this to be negative 1. Are you seeing? When the power of delta is 2, we put this to be negative 2. That negative 2, that one will be just for denoting a backward formula. It is just for denoting a backward formula. Are you getting that? But for denoting a forward formula, you just leave them not. That's why I'm not putting the nots here, because we don't know when we'll be using the backward and when we'll be using the forward, okay? Are we together? Good. Let us go to the next one. The next one, you want to evaluate f of 4.5. So right here, you are f of 4.5. So start. When is the x value 4.5? Because this is f of x. When is the x value 4.5? See, 4.5 is between 4 and 5.
Yes.
Meaning 4.5 is here, isn't it? Meaning your x0 is there and your x1 is there now. So we are now done with this one for forward. We are now in the backward, isn't it? Are we together? So it means the value we are evaluating, 4.5 is in the middle here. 4.5 is in the middle here. So you put a line where your value is. You put the line. Are we together? Are you seeing where you put the line? Your line is here. So look here. The value you want to evaluate 4.5 is here. So look, when you move forward, you will only have one value, meaning the forward difference formula will not work. Are you seeing?
Yes.
But if you move backward, are you seeing you'll have many values? Are we together? Yeah. So it means it is the backward difference formula which is working at this point. Are we together? It's the backward difference formula, because if you put the ruler here, you move forward, you will only see only one value. Only one value is not enough to evaluate an interpolation polynomial, isn't it? But if you put your ruler here, if you move forward, if you move backward, you are going back to the smaller x values, you can see you have 3 values, 1, 2, 3. Are you seeing? Are we together? Yeah. So you draw the line on the values you've reached. You cross your line for the backward formula. So you see the line where you are going to evaluate 4.5. Is the concept being understood now? Are we together? Very good. Now, look at now what the backward interpolation polynomial is going to look like. Meaning, f of x, you just take it from this forward formula. Here is just your f naught, because we have delta is not there, meaning delta to power 0, isn't it? Then here we have plus p delta f of negative 1, because the power of delta is 1 there. Silent, isn't it? Are we together? Yes. Then the next one is p into p minus 1 over 2 factorial. Then here we have delta squared f. So note it is now the negative 2. The power of delta is 2, that is 2. So this negative 2, negative 1 f naught is used to show it is a backward difference formula, just for notation. How do we note the f's when it is backward, and how do we note the f's when it is forward? Are you seeing that? Yes. Meaning here we just leave them as f's, because there's a time when we are going to note them for the backward, and there's a time when we are going to note them for the forward, isn't it? Are we together? Very good. So can you evaluate? Get for me b at this point. At this point, you have your x naught is here, and what is the value of x naught? And you have your x1 is down here, and what is the value of x1? And you have your x is in the middle here, and the value of x will be told is 4.5. So when you are looking for p, it is this smaller interval, meaning it is x minus x naught, isn't it? Then over this longer interval, which is h, x1 minus x naught, isn't it? So when you are looking for p, it is x minus x naught, that small interval, isn't it? Then you divide by that longer interval, the h, isn't it? Are we together? So what is p? Start. X minus x naught, 4.5 minus 4, 0.5 over h, the whole of this interval, 5 minus 4, 1. So what do you get to be p? P is 0.5. Meaning when you are evaluating f of 4.5, it implies you are going to take p to be 0. Then all this, your f naught, f negative 1, f negative 2, that means those are our backward values, and we already have them there with the line is showing us which values we are taking, isn't it? Are we together? Good. So come back, having found p, so now get f of 4.5. So what is f naught? Go where your 4.5 is. What is f naught? Here. So it means this is now f naught, f negative 1, f negative 2, f negative 3. We cannot put them there because there's a time when they are forward, there's a time when they are backward, isn't it? So your f naught is, the first value of f is, are you seeing that? The first value of f is 17. Then it is plus p, p you found is 0.5. So p times delta f, the first one, so when you are from that, what is the first delta f? 7, meaning this delta f is 7. That negative one is just to you denote the backward difference, okay? Are we together? Then after negative 7, it means your p is 0.5. Then 0.5 minus 1 is negative over 2. Then delta squared. So when you are here, what is your delta squared? Which value is there? Are we together? So when you are under the column of delta squared f, you get the value is 2. That negative 2 is just used to denote that we are dealing with a backward formula. Okay? When the power of delta is 2, it means we have negative 2. When the power of delta is 1, we have negative 1. When delta, the power is 0, it means delta is not there, we have f naught, isn't it? But forward, it is just f naught all through. Okay? Are we together? Yes. Good. Use a calculator and get the answer. Key in the old value, 17 plus 0.5 times 7, by that. That is 17 plus, what is 7? 0.5 times 7? 3.5. 2 divided by 2 factorial. Then 0.5 times negative 0.5. So what do you get to be the answer? 20.25. Are we together? So have you seen, we've used the Newton-Gregory forward difference formula and the backward difference formula. Forward difference formula for the f of 1.5 and the backward difference formula for the f of 4.5. Yes?
I have a question.
Yes.
Are we not supposed to use 9 for 17?
Here.
Yes.
Delta f, you can see this is the delta f. What is it? Remember, we are here, we are moving backward. So when we are here, the first f is 17. The first f, which is that, 17. Then we are moving backward. When you move backward, which is the next value? Are you seeing? Where are you moving? Are you seeing the reason why I'm putting the ruler here? When I move backward, which first value do I reach? For the delta f, which value do I reach? This negative 1 is just to note that I'm moving backward. Are you seeing? Then after negative 7, which is the next value I reach there? Are you seeing? But no, this one, look here. When you are here, when I'm moving forward like this, which is the first value I reach? Then, which is the next value I reach? Meaning forward, the ruler is here forward. The values are on top of the ruler. The values are always on top of the ruler. When it is forward, you can see I was here, then I'll move forward. The values are always on top of the ruler. 3, 2, 1. When now I'm at this point, the backward formula, I'm like this. The values are always on top of the ruler. Are you seeing what is happening? What is below the ruler is blocked. We are not dealing with that. Are you seeing that? Yes. See, what is on top of the ruler is what we are dealing with. It's what we are evaluating. Huh? Have you understood it? Yes. Yeah, when you are here in the forward difference formula here, if you move forward, which values do you see on top of the ruler? Delta f, delta squared f, delta cube f. When you are at this point, you are moving with the backward difference formula, which values are on top of the ruler? 7 for delta f, 2 for delta squared f naught, 0 for delta cube. Remember, what is below the ruler is always blocked, isn't it? You are okay? That is what I expect. You have to understand that. So it means you will only need that polynomial when you are evaluating a value which is not here. For instance, when somebody tells you to find f of 10, so you can see there is no value of f when x is 10. Are we together? Very good.